Welcome back everyone. In our class today, we will continue with data processing packages and will study the Matplot for data visualization in Python. We have talked a lot about data and data sets, and a key part of dealing with data is to be able to clearly visualize key insights about it, such as plotting certain variables, looking at the distribution of our data, and many more. To help us with this visualization, we will use and explore the Matplotlib. Matplotlib is a comprehensive library for creating static, animated, and interactive visualizations in Python. The Matplotlib works with Numpy Arrays best. When given other types of input, the Matplotlib functionalities may not work properly. Hence, it's better to always convert our inputs to Numpy Arrays. The library graphs data onto figures and gives users the flexibility to customize these figures and graphs to best highlight their data and purpose of those figures. This image shows you the different parts of a figure. There are two main ways to use Matplotlib. The first is by explicitly creating these figures and axes and calling methods on them, and this is referred to as the object-oriented style. Or we can use the Pyplot API to automate the creation and management of those figures and use the Pyplot functions on the created figures. In this class, we will learn and focus on Pyplot as our method of choice. Let's start with the simple plot. First, we will import the matplotlib.pyplot library using the following command. Then, we will use the plot function to plot our array. The ylabel method will allow you to label your axis, as you can see. Finally, to print your plot, use the method show. This demonstrates how fast it's to visualize an array or a list using Pyplot. You may notice that we only provided one list. Pyplot in this case assumes that these are the y values of our plot and generates the necessary x values for them. And you can see that the x-axis starts from 0, as the x-axis is simply the index for every y value. And as Python indices starts from 0, our x-axis is initialized to start from 0 as well. The plot function within Pyplot is very flexible and will take any number of lists or arrays. If we want to plot x versus y, we simply provide both arrays and the plot is displayed as it shows. To design our line, we can simply add the design parameters to our plot function. This is a list of all available parameters that we can specify for every line within our plot. For example, to change the color of the line and its style, we use the following properties. What if we want more than one line in our plot? The fastest way to include multiple lines within our plot and directly provide our design preferences is as follows. We are going to start using the Numpy Arrays as it's very easy to use and compatible with the Matplot functions as we described earlier. The Numpy Array signal contains the numbers from 0 to 5 with 0.2 step size using the arrange method as we saw earlier in the previous class. The first three parameters in the plot function correspond to the first line. For this line, we will draw a linear function where both x and y axes are equal to signal. The third input describes the properties of the line. R stands for red, and the two dashes describe the line style. Then the second three parameters correspond to the second line, where the characters BS stands for blue squares, and the last three parameters correspond to the third line, where those characters stands for green triangles. You can read more about the plot method using the following link. Now let's look at a real-life example of what we call time series data, which is data reading taken at steps of time such as electricity consumption, temperature readings, or even current readings taken from electrical machines. In this example, We are creating 5 dates using the datetime module in the x-axis, and we are pairing these dates with 5 random numbers between 0 to 100 in the y-axis. As you can see, the append method works differently in Numpy Arrays. As the method appends the new data to the old data, then it should be assigned to a Numpy array. Let's look at the commands to give a title, axis labels, and changing the size of our plot. In this example, we are creating a function that calculates the output of the following mathematical function and plot it. The exponential function calculates e to the power of x, where e is the Euler's number. The cosine function calculates cosine of a number x. The pi function will return the number pi. Pyplot makes it very convenient to work with subplots. The subplot method takes 3 parameters. The first number refers to the number of rows for your subplots. The second number refers to the number of columns for your subplots. Both of these numbers act like coordinates of the subplots. The third number indicates the order of the subplots. In this example, we are plotting 2 functions with their respective orders, as you can see. The text function can be used to add text in any location within the figure. The 2 numbers are the x and y coordinates for the text. We have covered the basics of plotting, and we will delve deeper into Pyplot in the next video. See you there.